What you are watching is an actual demonstration of a method for teaching algebraic concepts to elementary school students. As they solve their equations, these children are not only building a strong foundation for later algebraic studies, they are also developing a positive attitude towards mathematics and enhancing their sense of self-esteem. Hello, I'm Henry Borenson, and I'm here to tell you about this remarkable program. The children you are watching are just a few of the thousands who have gotten a head start on algebra with the Hands-on Equations learning system, a system that provides an easy and enjoyable introduction to algebraic linear equations. With Hands-on Equations, a child can transform an abstract algebraic equation into a physical setup and then physically solve that equation. With Hands-on Equations, it's possible to have third, fourth, and fifth graders actually solve algebraic linear equations such as this with an enthusiasm normally reserved for craft activities and sports. Hands-on Equations accomplishes this by representing abstract algebraic linear equations concretely through the use of these game pieces. The children are then able to move these pieces according to rules that translate the laws of algebra into a sort of game, a game which gradually evolves as additional elements of algebra are introduced into the play. Since balancing an equation is central to algebra, the easily grasped symbol of a balance scale is used. The demonstration scale enables the teacher to show solutions to a whole class at a time. The students follow along on a two-dimensional representation of that scale. The x is represented by a pawn, and number constants are represented by number cubes. The children use these pieces to solve algebraic linear equations by making legal moves that correspond to the abstract methods used in solving such equations. Let's show how a third or fourth grader would actually solve an algebraic linear equation such as this using Hands-on Equations. Since the problem calls for 3 x's, and since x's are represented by blue pawns, we will place 3 blue pawns here. The problem calls for an additional x, and so we're going to place 1 more x on this side. We also need a 2 constant. That is represented by a red 2 cube. On the other side of the equation, we have 2 x's and a 10 constant. We represent that, 2 x's and a 10. At this point, the child has now transformed an abstract algebraic equation into a concrete physical setup, and from here, it is easy for the child to solve this. After a few lessons in a program, the child learns the concept of a legal move. A legal move is a move that leaves a balanced scale in balance. For example, the child learns that it is all right to remove a pawn from one side provided a corresponding pawn is removed from the other side. Doing that 1 more time, the child simplifies the equation further. From here, the child can see that each x is worth 4. If the child does not see that, he may perform an additional legal move, namely to take away a 2 value from this side, a 2 value from this side, making this 10 into an 8. Now the child can see that each x is worth 4. And the child writes the answer this way. In order to be sure that the answer is correct, the child now checks his answer in the physical setup. So let's set up the problem 1 more time. We have 3 x's, have another x, and we have a 2. And on this side, we have 2 x's and a 10. Let's now see if x equals to 4 works. 4, 8, 12, 16, and 2 is 18. 4 and 4 is 8, and 10 is 18. So 18 equals 18, and both sides balance. The child writes his check on the board this way. 18 equals 18, And since both sides balance, the child now knows that 4 is the correct answer to this algebraic equation. By the way, notice the mental arithmetic which a child uses in doing his checks. And so, at an early age, the child is learning significant algebraic concepts. For example, when the child removes a pawn from each side of the setup, the child is physically carrying out an important algebraic principle called the subtraction property of equality. While hands-on equations doesn't attempt to teach such terminology, the child does become familiar with the actual algebraic principle involved. By structuring the learning experience in this manner, the child approaches algebraic linear equations at a concrete level. Later on in the program, the child learns a pictorial method for solving algebraic linear equations. With this concrete and pictorial foundation, a child's chances for success in later formal algebra is systematically enhanced. Indeed, many of the adults who today still experience algebra anxiety do so because they were initially presented to algebraic concepts at the abstract level. The need to have a concrete and pictorial introduction to the subject was largely ignored, making the learning task much more difficult. You see, the purpose of hands-on equations is not to provide young students with 9th grade algebra. The purpose is to provide them with a concrete and pictorial foundation that will enable them to succeed in their later algebraic studies. Hands-on equations consists of a total of 25 lessons comprising 3 levels. The children whom you saw at the beginning of this program were in Level 1. Level 1, consisting of the first 7 lessons, is designed to be used with good 3rd graders or average 4th graders. And since it is only 7 lessons, it can be easily incorporated into any mathematics program. In Level 2, the students are introduced to the white pawn representing negative x. In Level 3, the children are introduced to the green cube representing the negative constants. These symbolic pieces and the balance scale form an abacus for solving algebraic linear equations that can provide amazing results for a wide variety of students. And of course, hands-on equations will be of value to any students prior to taking a formal course in 9th grade algebra. For that reason, some districts prefer to use hands-on equations as a regular part of their junior high school pre-algebra program. At this point, I would like to show you 4 examples of the hands-on equations learning system in use. While these students work through their solutions, you will see how their moves correspond to the algebraic concepts involved. As you watch them solve their equations, I'd like you to think about how you could apply hands-on equations in achieving your goals. For our first demonstration, we'll watch Marco solve an equation from Level 1. Marco is an average student in the 4th grade.
Double x plus 3 equals 9 plus x. We're going to double each one paw and 2 3s. Double and 9 and 1 paw. First, I take a paw from each side and then see that each paw equals 3. And I go to the board and I write x equals 3, and I put them back, and then I add, because each paw equals 3. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, and 3 plus 9 equals 12. So I got 12 equals 12. I put a check to say that I checked the problem.
For our second demonstration, we'll have Susanna An average fifth grader show a pictorial solution to a level 1 equation.
What I'm going to solve is 4x's plus 2x's equals 1x plus 1x plus 20. I'm going to show you a pictorial solution. Four x's plus 2x's equals 1x plus 1x plus 20. First, I begin by removing 2 x's from each side. 4 x's is equal to 20. So x is equal to 5. So 5, 10, 15, 20, 25, 30. And 5, 10 plus 20 is 30. So we got 30 equals 30.
Now we'll have Susanna solve a level 2 equation.
My equation that I'm going to solve is x plus 10 equals 3 stars plus 2.
Star is the opposite of x.
X plus 10, 3 stars plus 2. First, I begin by taking 2 from each side, and my 10 becomes an 8. And I'm going to get rid of my x, and the way I do that is by adding a star to each side and taking this away. Now I can see that my star is equal to 2. And my x is equal to negative 2. Now I begin to check my problem, and I rearrange it the way it was. Ten minus 2 is 8. 2 plus 2 is 4, plus 2 is 6, and plus this 2 is 8.
And finally, we have Gordon, a gifted third grader who will solve a level 3 equation.
2 star plus negative 5 equals 2 plus star. 2 star plus negative 5 equals 2. First, I'm going to add positive 5 to each side. So I have 7 and 1 star here, and 2 star and positive 5 and negative 5 here. So I take positive 5 and negative 5 away because they're 0. And I can take a star from each side. And I'm left with 1 star on the other side and 7 on this side. So the star equals 7. And to check the problem, I put it back to the way it was. Seven plus 7 is 14, plus negative 5 is 9, and 2 plus 7 is 9. So check is 9 equals 9.
And in case you are wondering whether the children can transfer this learning to the traditional written notation, the answer is an unequivocal yes. Let's watch how Stephen, a gifted fourth grader, does this.
2x equals twice negative x plus 4. And if we add 2x to each side, and I'll have, so the negative x and x equals 0. So on this side it's 4 and 4x. So x equals 1 and negative x equals negative 1.
These children now have a strong foundation for success in later algebraic studies and an enhanced sense of self-esteem because of their success with hands-on equations. Testimonials offer dramatic evidence of the effectiveness of hands-on equations. From a professor of education at Teachers College, Columbia University, A. Harry Passow. Hands-on Equations is a remarkable program for teaching basic algebra concepts to all children. This creative innovation makes algebra accessible to young children. From fourth grade teacher Janet Gadachek. It was most gratifying to see children of different abilities all able to comprehend the idea of balancing the equations. And from elementary school principal Richard Eldridge. It is an exciting hands-on experience that not only sharpens algebraic skills, but also provides tangible growth in logical thinking and problem solving. We plan to include the program in the 3rd to 5th grade math curriculum next year. Dramatic testimony to the benefits that the hands-on equations learning system can deliver for your students. And best of all, it's easy to use. Each hands-on equations learning system comes with a simply written, illustrated guide that makes learning how to use the system literally child's play. Class sets are available for teacher and 10, 20, or 30 students. Each class set includes the demonstration scale, the demonstration game pieces, these sturdy student kits, and worksheet reproduction rights. That means that you can use the same materials year after year on your initial investment. Now, isn't that cost effective? We are so confident of the success that you will experience with hands-on equations that we offer a 15-day money-back guarantee if you are not satisfied for any reason at all. The time to build your students' mathematical power is now with hands-on equations.